512M represents an unprecedented memory depth for oscilloscopes. The waveform of 128 milliseconds can be sampled under a high-speed sampling rate of 4G, while a waveform of up to 7.1 hours can be sampled under a low-speed sampling rate of 20K. This is the most obvious appeal of data mining oscilloscopes. To manage massive waveforms, we continue to use the ZDS4000 series ADC plus DSP plus FPGA hardware architecture, but upgraded the original monolithic FPGA to a multi-core FPGA array system. In addition, multiple transceivers at a speed of up to 10 gigabytes per second were used for communication purposes between FPGA array chips. And the total access bandwidth for the deep memory unit even reached 400 gigabytes per second. The interaction of thousands of I/Os inside the FPGA array was required to adopt 10-layer PCB process, and its internal high-speed communication posed a great challenge to PCB materials. Meanwhile, to maintain the effective heat dissipation of the multi-core FPGA array system, we tried to improve the dissipation capacity of the system in all aspects, including the air ducts design and the structural design of radiators, including multiple calculations of the thermal coefficient of silicon grease. Eventually, we formulated a final solution. Our persistence ensures excellent performance that redefines the analysis process of data mining oscilloscopes. The data mining was based on 512M original waveform data. Supersized memory maximized the advantages of the 4G sampling rate. Even after prolonged waveform capture, the waveform would not be distorted due to a decline of the sampling rate. Next, ZDS4000 series oscilloscopes would capture abnormal waveforms at the capture rate of 1M. This capture rate helped minimize the dead time in order to ensure that the oscilloscope could capture abnormal waveforms at the fastest speed possible. What should we do when abnormal waveforms were found? The True Parameter Measurement and Statistics could thoroughly analyze 51 parameters of 512M waveform data, including the maximum value, minimum value, average value, and standard deviation of each parameter. Using all hardware acceleration ensured that all measurement results were instantly visible. With the measurement results of abnormal waveforms, we were only required to use them as search conditions to identify all locations with abnormal waveforms. With reference to the marks, all interested signals were crystal clear. Finally, we were required to apply various analytical plugins for specific analysis. The ZDS4000 series oscilloscopes were equipped with 30 kinds of serial protocol decoding, 4 channels of hardware FIR filter, dual zoom observation mode, waveform fragmentation storage, customized formula calculation, FFT spectrum analysis, waveform offline analysis software, and many other analytical plugins. The preceding paragraphs are the analytical process for data mining oscilloscopes, which are based on a dual touchscreen for operation and accompanied by an in-depth customized knob. These oscilloscopes provide a disruptive experience in both product performance and operation method.